Good afternoon, everyone. This is Sadia Zafar from HRAI. I would like to welcome you to today's session on retrofitting high rises with air source heat pumps. In this webinar, HVAC experts from Homestead Land Holdings and B&H will speak about the results of a 2-year energy study they conducted, which led them to retrofit 2 of their high-rise buildings with Panasonic air source heat pumps. A little bit of housekeeping. You will notice on the control panel of your screen the Q&A feature. Please use the Q&A feature to ask your questions at any time during the webinar. They will be addressed at the end of the session. Also note, this webinar is being recorded and the recording will be shared with you following the session. We will begin the presentation with Nick Bischoff. Welcome, Nick.
Thanks, Sadia. So yeah, today I'll be starting off with Panasonic and B&H, and then Jason will take over from Homestead and talk about the installation. And then Sunny will come in at the end and just give a bit of an introduction about Breathe Well, and Sunny from Panasonic as well. And next slide. And so I'll start with a case study of 41 Spears. So 41 Spears is the first building that we've done the full retrofit. And then also another building that we've done as well at Homestead. And so I'll start with the design review. That'll be about one of the pilot projects we did at 41 Spears, and then how the rest of the units were designed. Some ongoing analysis and monitoring of these pilot projects, energy results from them, and payback analysis on the total building. Then Jason will come in with some technical aesthetic challenges, project management, lessons learned, tenant feedback, and then Sunny will go to the introduction to Breathe Well, and then some Q&A. So a little bit about 41 Spears here. It's got 18 floors, 135 suites, a mix of 1, 2, and 3 bedrooms, and built in the 70s. The current system it has was PTAC units, and the full retrofit construction was started in July of this year and expected to be completed within the next couple of weeks. Next slide, please. So here's a floor plan at 41 Spears. Not only, like I mentioned, there's 1, 2, and 3 bedroom layouts, but they've all have slightly different configurations. So it made it a little bit difficult on the installer side to have to deal with just that little bit of variance. But the main benefits and goals of the project were to get more efficient heating and cooling, improve air circulation. So some of the tenants have already mentioned living in these upgraded suites that they could really feel the heat or the cold instantly after turning on the units, whereas the PTAC would kind of take a while to really kick in. And also occupant comfort. So each space could be controlled separately. So the living room and bedrooms can be set to various temperatures, just for better comfort overall. And next slide, please. So to begin with the pilot projects, it's been just over 2 years now that we started with a 1-bedroom and a 2-bedroom layout for the pilot projects. To do this, we had to determine the indoor and outdoor unit locations, as well as the sizing of them, determine how many tons we figured they would need. For electrical, we luckily had the PTAC units had a 220, so we could just use that for the full electrical needs. And then the goal with the pilot projects was really to get about a year's worth of data or so of electricity, indoor and outdoor temperature, and humidity, to figure out and make sure that these units were really going to do what we thought they were supposed to do. Next slide, please. And so a little bit of closer look into the design review details. The existing PTAC was located on the bottom of the floor plan there between the living room and balcony. So it would be removed. Then the outdoor unit would sit on the balcony. The indoor units would go along the interior wall through the middle of the floor plan there. We'd have a wired and wireless thermostats available. And for condensation concerns, if the condensate line couldn't be gravity fed, then condensate pumps would be installed within those indoor units wherever required. And next slide. And so, yeah, going to the ongoing analysis and the energy monitoring. So we had two of the existing PTAC units we monitored, and then two of our upgraded air source heat pumps as well monitored. So we could directly compare the two. And this is just a small sample size of the building, but it would give us, some good results to move forward with and to look at the total building analysis. The temperature data was kept inside to make sure on the coldest days of the year that the heat pump was keeping up, and as well in the hottest days of the year that the heat pump was keeping up with the cooling side. And next slide. And so here's a look at the average of the pilot projects. So the average of the two suites of each type we took here. The PTAC unit using about $750 over the year, and the heat pump down to about $235. So about a 68% savings here. The first couple months of the year on the left side of the chart there, of course, is looking like the highest amount of total savings. But each month we'd see at least typically 50% savings on the electricity. And next slide, please. So using this data, we decided to move forward with it and apply for an incentive for the total building. So this analysis was done slightly differently versus just using the pilot project, but it was actually looking at the total building, looking at all the COPs and SEERS numbers and all of that stuff to come up with this total building analysis. And the numbers came in slightly higher at 72% savings. So the PTACs will be using about 267,000, while the heat pumps down to about 73,000. And next slide, please. So these tables are showing the same results as the previous slide there. So the total building electricity load currently would be about 2.2 million kilowatt hours, and then down to the post retrofit of just over 500,000 kilowatt hours. And per square foot, that looks like just over $2 a square foot currently, and down to about 50 cents a square foot after. This data was third-party verified, and we used it to apply for a Save on Energy incentive. But right now that incentive isn't available. It's changed slightly, but there's another really good incentive through the Canada Greener Homes Grant that's available right now. And next slide, please. So using that data, we've combined it into a simple payback. Some of the notable parameters here were over 190,000 in first year electricity savings, incentive at about 175,000. The maintenance would be reduced, but definitely not completely gone, as there's still some maintenance to do with the heat pumps. And utility inflation would be considered, as well as carbon tax considered. So with this upgrade, we aren't going to see a huge carbon reduction, but if we were comparing to a gas-fired building, we would definitely see a larger reduction. And as the carbon tax continues to grow, that would become a larger amount. And next slide. And so this is what it looks like over a 30-year accumulated cost comparison. So at about year 5, we see the simple payback. And at about year 20, we can anticipate the equipment replacement. And this would only be the equipment side, not the actual copper refrigerant lines that are running, the electrical work, and all those things would remain in place, but we could simply swap out the equipment. Over these 30 years, we're looking at almost $13 million in electricity savings, which is obviously quite significant. And yeah, so that's the end of my section, and I'll pass it over to Jason, who will get into all the little details.
Very good. Thanks. Thanks so much, Nick. Thanks, Sadia. Thanks everyone else for joining us. So I figured I'd start and just let you all know a little bit about Homestead. If you don't know us, we're growing to become one of Canada's largest rental companies. Over 250 buildings, 27,000 apartments across 21 cities in Canada, mostly in Southern Ontario right now. We have a couple of buildings out of the province, but generally focused in Southern Ontario right now. Could I have the next slide, please? We own many buildings of all different ages, lots of them being 30 years old or more, with lots of dated heating systems and various types of envelopes, as I'm sure many people are familiar with these aged buildings and the varying levels of efficiency that we get out of both the envelopes and the heating systems there. Homestead also build brand new buildings. We have a division that we add nearly 100 new rental apartments each year. We have 2 or 3 buildings under construction or more at any one time, and continue to just keep rolling out new apartments. If we could have the next slide too, please. We also have an in-house sustainability and energy efficiency committee, where we look at new innovations that are on the market, different products and systems, and see how they fit with different types of buildings. And with our varying portfolio, we do tend to look at a lot of different things, and obviously the air source heat pumps seems to be a good target for trying to reduce our costs and make our buildings more efficient. So if we could go to the next slide, please. We look at it and we ask ourselves, why would we want to consider these air source heat pumps as a retrofit? But easily the first one, older systems having poor, inefficient technology, it's downright wasteful. Some systems have cooling integrated, most do not. And the ability for tenants to be able to control the systems, it's not always there to keep them comfortable. And obviously older systems, more ongoing maintenance, more increasingly expensive repairs. It doesn't make it an efficient and a sustainable system going forward. So the next slide, please. We have many buildings that are bulk metered. In this particular case, the buildings we're talking about, 41 Spears and 200 Queen Mary, they're both electrically heated. 41 Spears has the PTAC units, as Nick mentioned, that we'll get into. 200 Queen Mary is an odd building. It has radiant electric heating in the concrete slab, but the tenants' thermostats typically control the floor of the slab above them, the slab over their head. And so there's these difficulties in heating the building. When you call for heat on your thermostat, you're cooking your neighbor above. And so something like that, it was a bulk metered building, so tenants would just crank up the heat as much as they can, obviously trying to make themselves warm, and just not very efficient at all. And they don't pay the bills, so they just try to do whatever they can to make themselves comfortable. The next slide, please, is more about that. Tenant comfort. They can't control their own systems. They have hot spots or cold spots. And if we could decentralize these systems, some of these central plant shutdowns won't maybe affect as many people inside the building. And obviously air source heat pumps would provide cooling where there was no cooling before, which was a serious benefit and a big selling feature. Actually, a lot of the tenants found that they were very, very, very over the moon to get cooling in their new systems where they didn't have before. So if we could go to the next slide, please. After we figured out that we were going to jive in and do these things, we had to start understanding the components. Nick went through the very nice design concepts and the way that the system is, on paper, kind of plugged into the apartment. But this is where the rubber hits the road, and we have to look at all of the different components. So obviously you can see here we have the outdoor the outdoor unit on the left, the condensing unit. On the right and the top, you can see the indoor heads that are hanging on the wall in each of the rooms. and different controllers that are obviously going to be much different than tenants are currently used to. So there's a bit of a learning curve coming up with that. For the next slide, between some of these equipments, there are these line sets. They consist of copper piping that's insulated, there's drain lines, and there's control wires, and they have to run between all of the indoor heads, as you see up at the top, to the outdoor head that's sitting on the balcony. So those are some of the things that we have to look at. How do we try to plug these systems in and get them into our apartments where we're not building new, we're trying to retrofit, right? For the next slide, please. The condensation, I noticed there was a question there, and we can get into this a little bit, but there's tubing there, there's the pump system is that little blue thing in the middle there that fits either inside the head or somewhere in a bulkhead, and all the condensate needs to be captured inside of a vertical riser. And the photo on the right shows the vertical risers that we install outside in the balcony between all the floors. They go floor to floor, and we can drain them down out onto the onto grade down below. And I just see the question there from Sarah. We'll get to that in a minute. Sarah's got a couple of questions that I'm going to be covering as we go along, so it's great. If we could go to the next slide, please. So getting into this line set routing, and how do we conceal them? How do we make them look nice? And what do we got to think about? So obviously the physical building considerations are serious. We don't want to make too many structural openings. I mean, nobody likes trying to core through concrete walls just to run some pipes through. Trying to maybe reuse some existing infrastructure there, dealing with existing ceiling heights. Nick mentioned the electrical supply, which can be an issue in some apartments where the electrical panel doesn't have the necessary breakers. We just ran into this where in the one building, the one apartment doesn't have the proper breakers, and it's a 30-year-old panel, 40-year-old panel, I guess. And we can't get a 30 amp breaker for that panel anymore. So we have to just go and replace all the suite panels. It's going to cost us less to replace the panel and then get the proper breakers just to deal with that solution. So I guess understanding what the existing building has to offer is key. And obviously you can hear, so some of the installation considerations I'll get into as I'm showing you there, reuse existing infrastructure, trying to get them inside the walls or surface mounting and things like that. If we can go to the next slide. Here for the line set routing, we tried to reuse some of the existing openings. You can see those pictures. The holes there were from the old ductwork that the PTACs had used. The photo on the right shows the living room. There used to be a PTAC unit installed, if you can see the opening through the window, and we're running the line sets up through the wall, through the ductwork that was running to the other bedrooms and other rooms. So there's drywall repairs that are inevitable with these types of things, and there's other ways to try to figure out how we can conceal and make some of the other line sets look kind of nice. If we could go to the next slide, please. We tried a little bit, and I guess I should maybe preface by saying that a lot of these are kind of things that we were trying as we're getting into this, and as we were learning about these systems, we were learning what is possible, what's not possible, and also trying to shoehorn these things into the existing buildings. Thank you for your comment about asbestos, Sophia. I'll just get to that in a minute. These buildings did have asbestos in the ceiling. They all had textured ceilings with asbestos. So as you can see, we're running all the line sets along the walls, and we're trying to stay away from the ceiling. It creates many challenges for enclosing these line sets down the road. Even the height, as you can see on this photo, would make enclosing it with a bulkhead challenging. But the asbestos is something that we're still trying to get around. I'll get into a few slides later of some of the things. But here you can see that we were trying to bury the line set inside the wall with some limited success. Part of the line set disappeared and looked great. Top and bottom, there were little issues. It came out of the wall there in that small little picture, and it made it difficult to conceal. So we tried, there's also, this was an empty apartment, so it was vacant, but as you can imagine, we're cutting holes, we're creating a lot of dust. We have to sand, drywall, mud down the road once we repair. So trying to limit the intrusion into people's suites is a factor as well. If we could have the next slide, please. These line set covers are ways that we can conceal surface mounted line sets that just run on top of the walls. We're not trying to bury them anymore, with varying degrees of success. There you can see in a closet, it looks nice, a small little piece beside the head could be unnoticeable. The picture in the top right was not bad, but if we could see the next slide, please. There's some locations where it didn't work out because we needed to accommodate other line sets for other units. The line set groupings become sometimes too large to fit in maybe a single cover, or there are larger covers, and sometimes we didn't have them available at the time. Yeah, so some of this stuff was considerations for trying to push us in some other directions. The next slide shows some of our attempts to start to enclose some of these things. And as we discussed, the asbestos was an issue. If we go to the next slide, some of the design ideas that we had for, could we install wooden brackets on the wall and attach them to the wall and build out bulkheads over top of that? Could we speak to suppliers about getting metal or other pieces fabricated in L shapes or U shapes to try to screw on or glue on or other things? And so we're still trying to sort out what the best way is. We're trying a couple of different things and kind of seeing what's going to work out best for us. But we have to do something, and I'll get to some of that a little bit. For the next slide, in a case like this, it was very easy to build a vertical enclosure to hide all the line sets, and it seems to be a very nice enclosure. It kind of makes everything disappear. It looks like it almost was meant to be there, and so we found that was a very nice way to do it. Certain buildings, it worked very well. In the one building, 200 Queen Mary, wasn't really an option available to 41 Spears, just due to the existing building and the type of construction and the way that the units were oriented in each building differently. So for the next slide, we considered the outdoor unit location, and I see a couple of comments bouncing around here. So you can see here, we're obviously looking at the orientation on the right-hand side of whether it's facing forward, or like it's pointing towards us, or if it's pointing away from us. The space is definitely a concern. From our operations side, they wanted to know exactly how big these units were and how much floor space that we're taking up, and are we taking up 8 square feet of usable space on someone's balcony that could be already small. We have the middle picture here is a much smaller balcony. The two on the right are your kind of more typical 18 by 20 18 by 5 foot balconies. Less impact there, more impact on these smaller balconies. And obviously guardrail climbability is a concern that we're looking at as well. The unit on the left, as you can see, was put up on a stand. Different feet, different installations. The units on the right there have these other rubber blocks that go down. All of our balconies have waterproofing membranes on the top side, so we're trying not to bolt something down through our waterproofing and create more penetration. So the blocks work well, but the climbability is an issue. For the next slide, the orientation we actually looked at, and we actually installed some, and we had a couple of reports back saying, geez, when you go outside in the summer, when that thing's in cooling mode, it's blasting hot air on you. And you can see figure A down there in the bottom, when it's turned, it's pointing right at the balcony. I mean, if you wanted to try to go out and use your balcony for a little bit in the summer when your air conditioner is on, you get a lot of that heat blowing right on you. And obviously the smaller the balcony, the more difficult and more uncomfortable it could be. So then we decided to orient all of the units per orientation B, pointing outwards. So any heat kind of pushes out to the outside now. It would be the opposite in the winter. When it's cold outside, that unit's going to be blowing even more cold air. So, just not nice for the usability of the balcony, but something that we looked at. For the next slide, we looked at the enclosure penetrations between the inside and the outside, having to try to insulate and seal up around these line sets. It's not pretty, and it's maybe something that we could maybe look at improving upon. You can see in the right here, we started to look at maybe going through a window system. In this particular building, we're going to be replacing those windows. You can see they're quite old. I think they're in the budget 2 years from now. So we wanted to not put a whole bunch of infrastructure for the heat pumps through these windows that would make our window replacement more difficult down the road. We had other ideas to solve these things, but trying to think of all these things as we're going through. So the next slide talks about our project management. Homestead gives 60-day written notices prior to the work. Just if anybody thinks that they won't be able to deal with the construction during the process, they are welcome to, give their notice and unfortunately have to leave Homestead and find somewhere else. But we try to give them plenty of notice there. But during the work, we have a dedicated Homestead site person on site all the time. And one of their main focuses is specifically dealing with tenants. Our guy that we have here, he's been with Homestead for over 20 years, and he's been doing things like this for a long time. So he has those interpersonal skills, and he has that ability to kind of defuse tenants. He's the right man for the job, and that's very, very important, to find a person that can, take all the weight of the tenant's burdens and also still have, kid gloves to deal with them sometimes when you need to. So he was excellent to visit all the tenants of the units that we were coming up. So for a week, he would knock on everybody's door. He would speak to everybody. He would explain to them what they have to do, explain which pieces of furniture that they needed to move or what needed to come off the walls, and talk to them about, he was there to kind of help as well. Obviously, COVID-19 screening protocols and things that we're trying to do to keep everybody safe as we're working in their homes. It's important, and everybody who's involved with project management knows how critical it is to, keep the tenants informed and have them feel like they know and they're comfortable with what's going on in their homes. Obviously, we don't need to give them all of the information, but just giving them enough and having them hopefully be as cooperative as we can. Most of the guys are obviously our construction workers too, was good to make sure that the guys that are working there are all good. They're all able to deal with tenants, and we've had a lot of good feedback, positive feedback from both the site managers that we have specific to these projects, as well as the contractors that are on there. So the project management side, though, this was a very, very, very important piece to the whole puzzle that kind of gets lost with all of our design and our talk about energy and money and things like that, but this was absolutely critical. For the next slide, project management offsite, I guess, my job was fairly easy. All I had to do is just move a few pieces between the installers and the contractors, make sure everybody had all the equipment at the right times, and make sure that they're following up with some of the documentation that we require. During construction, we want commissioning sheets for each apartment and documenting serial numbers and model numbers. So we have to try to organize that for 2 or 3 or 4 units in each apartment of 137 apartments. Is it's not easy, but it's a nice big spreadsheet. Nick helps a lot with that stuff, so it's great to be working with him on that. And so I guess moving on, kind of some of the lessons learned. I chatted, talked about some of the stuff, but the biggest lesson learned was get your decision-making hierarchy down as you're going into it. And that comes with understanding the systems, understanding those physical constraints for the buildings, but then evaluate what's most important to you. Cost is obviously key. Aesthetics, speed, interruption to tenants, those are critical factors. On one hand, you could say interruption to tenants is very key because we're going in there, making holes, making dust, and inconveniencing them. But there's the flip side, there's benefits to that. Aesthetics was a big thing that we got through as we were going, as we kept getting our executive from Homestead involved, and we would run certain things past them, it became clear to us that aesthetics was very, very, very important. As much as nobody really wanted to spend all the money on aesthetics at the beginning, everybody kind of started to realize that they weren't really happy with some of those line set covers. And so if we had known some of those things going into it, we might have had a different approach. But as we were going, as we were learning, some of these other things became clear. And then obviously aesthetics was very important, and some things like speed started to unfortunately be sacrificed because the other things kept being more important. We knew that it was a test. We knew that we were trying to figure things out. So we decided to try to take our time and limit all of the other factors there. And obviously the long-term system that's going in there for 20 plus years. And I think that's one of the really big things that drives the aesthetics and what we can do. And then making the aesthetics, more difficult or more bulkheads also now makes our work inside the unit more intrusive. So I guess understanding what your personal, goals are in this respect is I think big. For the next slide, no one size fits all approach. All of those nice design ideas that Nick went off, very high level, and the engineering kind of side of it. It's great on paper, as we all know, and when you try to jam it into a building, it doesn't work. So trying to make some decisions, across the board would be difficult. If we did not have asbestos in these buildings, it would be completely different. We're also doing a full building in Ottawa, where they don't have asbestos, and they're able to actually, do creative things, prefab sections of bulkheads, so they can go in and just, install them quite quickly with very, very minimal dust and other intrusions inside the tenants' apartments. So some of those things were really key to kind of take the design concepts and try to implement them into the building. The next slide, just talking about speed and scheduling. Obviously trying to keep regular weekly meetings with look aheads is key. We always have project startups, as I'm sure everybody does, to kind of get the contractors set out and get all of the rules for working inside the buildings and inside the homes. But we also found, in addition to all of those regular things, each time they start a new unit, each time they start a new configuration, when we come up to something, you got to plan ahead, look at it a couple of days before, and get everybody on the same page with what needs to happen with both the aesthetics and some of the HVAC installs. Obviously regular updates and the usual regular updates and identifying labor requirements. Everybody is short on labor and materials for everything these days, which everybody is probably feeling the impacts. And so understanding what you need and when you need it is good to try to keep things moving, as we know. The next slide is really just oh, there we go. Really just talking about the tenants and some of the feedback that we get, and as we've all said, they're crazy about the new systems and the instantaneous heat, the instantaneous cooling. In the P-tax, we had some of them replaced over the summer, and everyone that you talk to, the first thing out of their mouth was that it's cold instantly, whereas those old P-tax took forever, and I guess, to kind of ramp up and start pumping out the heat, or excuse me, the cold. In the 200 Queen Mary building, they did not have cooling at all. So they now have built-in cooling in all of their units. In all their rooms. They only had an AC sleeve in the living room in those apartments previously. So you could have had air conditioning in the living room, but it wouldn't have really filtered down into your bedroom. So that in that building as well, with the radiant heat that was controlled in your ceiling, night and day. People are stopping us in the hall and asking us when we're going to be coming to their apartment to install their unit, because they just can't wait to get this thing, because people have lived there for 10, 15 years and have constantly had to adjust their system based on their neighbors, because they're too cold, so they have to call the person down below to turn up the heat. Now they just go to their controller and they turn it on and it's instant. It's amazing. They've also noticed how everything is more evenly heated. Nick didn't mention this, but we were looking at some of the data. He was logging the temperature differences, and it was no more than a 1 degree temperature difference it felt in the indoor environment when I think the coldest day was it -15?
I think it got down to at least 18 to -18, but
yeah. So at that temperature, I mean, a 1 degree swing of the unit inside is amazing, you know, and the tenants have nothing but excellent things to say. In addition, sure, you can connect your controller to Wi-Fi too, and so everybody can now go on their phone and they can adjust their unit. There's plenty of automatic settings for these units. They even have an occupancy sensor on them, so you can just set it and forget it. The tenants really like it. And that's really about all I have. I hope I got to answer any questions and would be available to answer any others down the road, but I'll turn it over to Sunny for now. Thank you very much.
All right. Thanks, Jason. Before I get on to the whole breathe well kind of story and a few slides that we have, I just wanted those last several slides talking about lessons learned and best practices. I mean, this was something started like 2.5 years ago where we essentially, you know, we installed a couple units as demo or pilot project units, and we really did a lot of energy monitoring. And all the stuff that you saw today, that didn't really come into play until Homestead said, yeah, we want to do this in our whole building. And then, even then, we thought we could, you know, we could kind of manage it from there. And then, as Jason said, once you get into the suite and you start taking the PTAC out and, you know, making holes in the wall and figuring out where to put the line set, it's all really about a lessons learned and best practice. And I think where we are today is just so far from where we were when we actually decided to say, you know what, let's do these couple buildings. And I think that's a real testament to Nick, Brian from B&H, and Jason and Homestead, just to really pull it all together and work together as a team to figure out. There was a lot of bumps and bruises, guys. Don't kid yourself. It's, you know, the finished product is nice, but we went through a lot. And I think today we can safely say, you know what, we know how to retrofit buildings with air source heat pumps. And we have the data to back it up, not only previous data to get you your return on investment, but just that data moving forward and really debunk the myth of, you know, air source heat pumps and, you know, can we use them in, let's say, Canada, for example, if we want to get really, you know, are they a way we can heat? But the cooling side of it is a key thing here, everyone. It's a comfort, it's a tenant retention issue. When we talk about Homestead, we talk about any companies that own properties and have a portfolio like Homestead. We're talking about how do we, you know, keep that monthly payment coming in? How do we keep that space occupied? And comfort has always been and has been for years the top 3 things. If they're not comfortable, they're going to go search out another apartment building or a place to live. So just wanted to give huge props to everybody on this call today. And there's also other people behind the scenes, you know, several, I don't want to say hundreds, but we've had so many site visits and meetings. And we also have, you know, our distributors that are there and contributing to the whole project management side of things. So really job well done. If you have any questions and you want to talk further about it, please contact us, Jason, Nick, myself, and we'll go forward. So only have a few minutes left here before we have some question and answers, but I really wanted to introduce Breathe Well. So this is kind of a unique play from Panasonic, who is a manufacturer of HVAC, IAQ, and smart control products. So what you see on the screen here is important. I'm going to read it out because I have a few minutes, because this is our mission, our passion statement, to our new indoor air quality campaign that we'll be launching. One of first of its kind, coming from a manufacturer. You'll notice that we're not talking about product here. We're really trying to get that emotional attachment to indoor air quality and say, you know what, be aware of your indoor air quality, the air you breathe. And you know what, at Panasonic, we can help you improve that indoor air quality. So don't just breathe well. We can take things for granted sometimes, like breathing. It's just something our body does on its own. We don't choose the air we breathe, we just breathe. At Panasonic, we believe you do have a choice to breathe well. We breathe around 20,000 times per day. Many of our breaths are unnoticed, some are special. but what they all have in common is they fuel, comfort, and energize us, making each and every one vital, not only to survival, but to our quality of life. Panasonic's air conditioning, air purification, environmental comfort, and ventilation expertise ensures our homes and workplaces have the freshest, cleanest air possible, free of harmful substances, so that only the healthiest air remains. So choose to breathe well, knowing that each breath you take, including every breath of delight, every breath of surprise, every breath of relief, and every breath of excitement, you'll not only be breathing well, but living well. Breathe Well, the only complete air quality solution by Panasonic. Next slide, please, Sonia. So it kind of, when I talk about indoor air quality campaign, you'll start seeing it starting in September. And what we're trying to do here is Panasonic is a leader in the indoor air quality space globally, by the way. And what we try to create is really an indoor air quality brand called Breathe Well, the only complete air quality solution. And really what we're based around is, you'll see that little circle, says clean, comfort, and fresh. So when we start bringing in all our technologies, whether it's heating and cooling, ventilation, air exchangers, air purification products, smart controls, we really touch on the clean, comfort, and fresh, and say, you know what, we can bring to your home or to your building the cleanest, comfortable, most fresh air possible. And how do we do it? We use Panasonic technology. And you'll see kind of below that circle, we got the clean, comfort, and fresh, and we kind of got, under clean, purification, and circulation, comfort, heating and air conditioning, fresh. We have the ERV and ventilation. And then the kind of pillar or the architecture below it is we really have a couple technologies, one through a partnership and one that's a Panasonic technology that can really tie this whole ventilation system together to give you your optimal indoor air quality. Next slide, please. And that's a thank you. So what I will say before we do go to the questions is, keep an eye out for Breathe Well. I mean, a lot of you on the call probably know the Panasonic brand, but we will definitely be launching the campaign in the next several weeks. I think start or mid to December, you'll start seeing it. And what we are doing is looking for Breathe Well partners on the builder developer side, contractor partners, and anybody kind of in between. And just keep in mind that, if you are looking for somebody to improve your indoor air quality, Panasonic Breathe Well has the solutions to do so. So once again, I want to thank Jason and Nick and everybody else behind the scenes that's really, take 2.5 years to really come to what we've been able to put together as a really cool, informative presentation. I mean, we can get down to the nitty gritty if you want to contact us, and we can kind of look at this project or these projects and really tell you some of the, some of the highs and some of the lows. But I think when we look at comfort and we look at energy savings and we look at our environmental responsibility, this is a way we can start doing now. You just drive, if you're in Ontario or even in the GTA, you just drive along the highway or the street and you look left or right, you'll see buildings, and you'll see a lot of times you'll see window shaker air conditioners sticking out of those buildings. Well, we know there's a need there for more efficient heating and a better cooling to get to not only your comfort, but also to get energy savings and to help the environment. So keep that in mind. And I think what we'll do now is we'll take the questions.
Thank you, Sonny. So we've had a couple of questions that Brian has taken care of it already. So in general, one of the questions is, what incentives are available?
So I was just going to put a link here to the Greener Homes grant. I'll send that out right now. And as well, the Save on Energy is the one that we went through for a couple of the homestead buildings. And they've got a couple different incentives now available. The Canada Greener Homes grant is probably the highest value that you can get right now. And I'm not sure if there's anywhere else. I'm sure there's some more incentives available out there as well.
So will you be putting this in the chat?
Yes. Yeah. So I'll put a link here. It gives basically information on how to apply for that incentive.
Perfect. Thank you. One other question is, what are the main building characteristics to look for when planning a potential retrofit?
Right.
Well,
Yeah,
I
go ahead,
think,
Jason.
sorry, to plan a retrofit. Maybe I'll let you go back on that to plan, Nick, sorry.
Yeah, and the planning, I guess it probably would be the electrical concerns as well as what type of unit you'll be using outdoors. If you're gonna you might need a balcony if you're gonna use those types of units, or you have to plan if you don't have balconies. If you maybe only some units have balconies, you could do like a VRF type of system. And just the interior space with everything, Jason, that you've talked about here to consider.
Yeah, and I guess that's where I was going to jump in. I mean, things like the asbestos is difficult, but if you're kind of looking at an overall, like which building do I pick, or which building do I start with, or what makes a building a good candidate, I mean, we started with basically the energy savings that we could get from switching the inefficient electrical heat to a more efficient electrical system. So that was like one of the driving factors. We did find, we did a test in a building that was better insulated. It actually had an overcladded eaves system. And it was actually a mid-rise building. It was only 6 stories. We found that it had PTAC units and then changed over to air source heat pumps. While the system was improved performance, it wasn't nearly as good as the other PTAC that was at Spears Road, where it was your old double brick assembly with I think about 1.5 inches of rigid insulation on the inside. So very inefficient envelope made the conversion a whole lot more interesting from a dollar's perspective. When the building envelope was better, I mean, I guess even those old inefficient PTAC units maybe weren't guzzling as much energy just because the envelope was keeping things a little nicer.
And I think from the Panasonic point of view and finding that is clients that are looking to change and want to upgrade their buildings and upgrade their energy systems and are adapting to the new technologies. That's a big hurdle to get over a lot of times, is people that aren't willing to learn new technology and want to move forward. So a lot of times we have to find guys that are willing to take that chance with us. And luckily, Jason's been great on site with us, working with us the whole time. So a lot of it has to do with the clients you find. And what we're hoping is this becomes the new normal, or to steal a phrase, or the status quo. And once we've kind of gone all through a lot of these growing pains and hurdles, more clients will come out of the woodwork and feel more comfortable with it, because it is a challenge. It's not an easy system to do in a large building, and it's a good undertaking. But when you look at a portfolio like Homestead has, it has a huge impact on the energy and their sustainability, responsibility to the environment, and to their tenants' comfort. So there's a lot of different things there, and a big thing is about the client's willingness to change and what they're looking for.
Okay, perfect. We just have a comment on like going from installed and service to wholesale, and retrofitting to these systems in the Okanagan Valley in the past has been difficult. So more government incentive availability may help. It's just a comment that's come up. I wanted to bring that to your attention.
I think that if you live in the Okanagan Valley, you don't have any complaints. That place is beautiful.
Well said.
I'll move there. I'll go. I'll make heat pumps happen in the Okanagan Valley.
A quick note before asking about the outdoor units and if there's complaints from the neighbors or anyone else. So I just quickly looked it up. The max outdoor sound rating is about 50 decibels. That'd be at full capacity, and that's roughly the same as a refrigerator running. So they are super quiet units.
Good to know. Okay, great. Thank you, everyone. So this ends our presentation for today. I hope our members found this informative. If you have any questions, please feel free to reach out to HRAI. Additionally, please complete the evaluation survey that will appear on your screen at the end of the webinar. And with that, have a great afternoon, everyone. And thank you, everyone.
Thank you all.